Good afternoon, class. Today we're going to be covering 7.3, the number E. But before we get into the notes, I want to do a little warm-up with you guys. So make sure you get your calculators out. Your warm-up is a question involving the compound interest that we talked about yesterday. The equation for the compound interest is down below. A equals P, 1 plus R over N to a power of N times T. Now, remembering what those mean, remember A was the total, the amount you get in the end. P was your principal, or the amount you put in. R is always rate, T is always time. N was the compound, and remember that changed. So when I'm looking at this question, it says you are trying to decide which bank to deposit $1,000 into over the next 10 years. We have two banks. Bank 1 has a savings account with rates of 3.79 and it's compounded monthly. Bank 2 has a savings account, rates of 3.8, compounded quarterly. So you should notice the rates are a little bit different. One is compounded monthly, one is compounded quarterly. Now, if you haven't started yet, I want you to start plugging those in. Okay, plug them into the equation, get an amount for Bank 1, and get an amount for Bank 2. Now, as you're plugging them in, make sure you relate what you have to what I'm writing. We're plugging in $1,000. My rate, remember, always move that decimal over. So 0.0379. Monthly is 12. 12 times 10. And then the second one, plugging in $1,000 still. 1 plus, pull your decimal over, 0.038. Quarterly is 4. 4 times, again, 10 years. And I want you to compare these two numbers. Compare these two totals. Okay, so you should be getting two totals right now. One for Bank 1, one for Bank 2. Now, just looking at what the question has, you would think maybe Bank 2 is going to give you more because the interest rate is higher. It's a little bit higher, but not much. But remember, when we talk about the compounds tell us how many times we're gaining interest. So when I think about that, Bank 1 is gaining interest 12 times monthly. Bank 2 is only gaining interest 4 times. So it's gaining interest a third of the amount of Bank 1. Now, looking at the totals that were received, was it Bank 1 or was it Bank 2? My totals, Bank 1, you would end up with $1,459.95. Bank 2, $1,459.66. So, Bank 1. It had the lower monthly interest of 3.79, but it compounded more. And the number of compounds adds more interest every single time. Okay, so key thing from yesterday, those compounds are a key component of that interest equation. Now, that was a little review from yesterday. Today, we're going to talk about 7.3, the number E. Now, yes, E is a letter, but E is kind of like pi, which you're going to see in a second. It's actually a number. Okay, well, what is E? Like I said, it's kind of like pi. You guys recognize pi as 3.14. So pi is a symbol that represents a number, 3.14. It's also kind of like I. Hopefully we recognize I as the square root of -1 when we have those square roots with negatives underneath. Again, I is a letter or a symbol, and it means square root of -1. Well, now we're going to add to that. Now we have an E. Okay, so this is going to be another thing that you're going to have to keep in your memory bank. E comes from this function. Okay, so I want you to take your calculators and I want you to graph this function so we can see what it looks like. The function of 1 plus 1 over x to a power of x. When we take this function, this is what our calculator shows us. Now, there's something about this graph that I want to make sure that we see. On this graph, right here in the middle, both of these lines approach an asymptote. So I could draw a dotted line through here. This position right here on the y-axis is where E is coming from. So this value right here of that asymptote is our value of E. And if you look at the picture, it looks like it's pretty close to 3. So E, What is it? E is your natural base. So anytime you see the word E or natural base, it's just like a pi, 2.7182818284459 ... Just like pi, it keeps going. But also just like pi, we're going to shorten it. You don't need to remember everything. You can remember E is about 2.718. So E is a number. It's called Euler, which is a good fact, but you don't have to memorize that. And it's the number that the following function approaches. And that was going back to this graph down here at the bottom. We said it was about 3. Well, if we reference that to what we said up top, it's 2.718. Okay, so anytime you see E, think of 2.718. Now, you have two buttons on your graphing calculators. You have an E button, that's right above the division, and you have e to the x, which is right above the ln button. Okay, make sure you're looking, make sure you find both of those buttons. Now, E is going to be used when you only want E. That's all you want. If you want a power, you're typing the E to the X button. That's going to ensure you that you can plug in that power. Okay, so you've got two different buttons that you can use depending on what kind of a question you have. Now, evaluating expressions. I'm going to give you a second while I'm talking. Go ahead and type these in. You have 4 E's on the left. I want you to see with what they match up with on the right. So again, if you haven't started, go ahead and start typing them in. I have E cubed. See which one that matches up with on the right. 4E squared, e to the negative 2, and 7 times e to the negative 0.52. Every single one of these on the left is going to be matching up with the ones on the right. Now, when you're typing them in, hopefully you're almost done, I would be typing e to the x and then putting a 3 in that x position inside of my calculator. And then same thing, 4e to the x and putting in a 2. Now, what'd you get for the first one? E cubed. Hopefully, you referenced e cubed of 20.09. How about the second one? Typed it in. 4e squared is 29.56. The next one, e to the negative 2. Type it in. You get 0.14. The last one, 7 times e to the negative 0.52. You should get 4.16. Okay, so this is just simple evaluating. Simple, plug it in your calculator, see what you get. Okay, and again, remember what E means. E means 2.718. So this is just like doing 2.718 cubed, hence the reason it was 20.09. Now, taking our rules that we've learned the last 2 chapters and dealing with E in the exact same way. Exact same rules that you learned in the last 2 chapters. Okay, so now we're simplifying. So take what we have and simplify it as much as possible. The first one, starting off nice and easy. E squared times E cubed. Same rules that we've had with numbers and with x's, but now we have e's. So this is a multiplication question. So I'm looking at my 2 powers, and since this is a multiplication question, what am I doing to my 2 powers? I have 2 e's, I have 5 e's, so I am adding them to give me how many? Now I have e to the 7th. I have 7 e's. Okay, so that was a simple one. Now let's get a little bit more difficult. The second one is multiplication. I'm going to choose to kind of treat these two separately. So starting on this first part, I see a 12 over 24 that I can reduce. So I'm going to start there. 12 over 24 is 1 half, 1 over 2. And then e squared is just going to stay for a little bit. Now I'm going to come over here. We have parentheses with a power on the outside. So I have power to a power. I'm going to pull this negative 2 inside here. So power to a power, what am I going to do since I have power to a power with these exponents? Power to a power, we know we should multiply. So this is going to give us e to the negative 10. Now I also have to remember I have to pull this negative 2 to everything on the inside. So the 3 also needs a power of negative 2. And this e down here, power to a power. So how many e's do I have now? This is now e to the negative 8. Now, hopefully we recognize all of these powers inside here are negative. So I'm going to have to take the e to the negative 10, move it to the bottom. The 3 to the negative 2, move it to the top. E to the negative 8, move it to the top. So this fraction is now 3 squared e to the 8th over e to the 10th. I had to take all those negatives and flip them. So what does that leave me with? 3 squared. I can go ahead and simplify that. So I have, let's start with this first part, I have e squared over 2 times, now simplifying this, 3 squared is 6, and I've got 8 e's on top, 10 e's on bottom. When I have e's on top and bottom, what's our rules? This is division, so I'm taking my 8 and my 10 and I am subtracting them. 8 minus 10 is negative 2, so where do my 2 e's belong? They belong in the bottom. Now, last step, I got a 6 on top, I got a 2 on bottom. 6 over 2 is 3. I have an e squared on top. I have an e squared on the bottom. Well, if I have 2 e's on top, 2 e's on bottom, they're going to cancel. So the only thing I'm left with is 3, which is my answer. Next part. Square root of 25 e to the 6x times 2 e to the negative 5x divided by e to the x. Don't let these x's confuse you. They're all x's. So let's just treat them the same way we've done everything else. So let's start with square root. Square root of 25. Square root of 25 is 5. This is a square root, so this is a 2 inside of my root. Remember, what are we doing here? E to the 6x means I have e to the x how many times? That means I have e to the x 6 times. Since this is a square root, I'm looking for groups of 2. So I have a group of 2, group of 2, group of 2. So I can take my groups of 2 out to the front, which means I have 3 groups of 2. So this is e to the 3x. Now when I take those out, there's nothing left underneath, so the square root's gone. Now the second part, I have a negative power, but remember that negative power is only attached to that e. It has nothing to do with this 2. So this 2 stays. This e to the x on the bottom stays. This negative power has to move to the bottom. So e to the 5x on the bottom. Okay, now let's start to combine. I've got 5 times 2 on the top. 5 times 2 is 10. E to the 3x over. I've got 2 e's on the bottom. I've got e, this is a 1x times e to the 5x. What am I going to do here? This is a multiplication, so I have 1 and I have 5, so therefore I have e to the 6x. Well, 10 is just 10. There's nothing I can do with it. I still got e's that I can take care of. I've got 3 e's on top, 6 e's on bottom. So 3 minus 6, this is division. So I have 3 e's left on the bottom. So 10 divided by e to the 3x. So using the rules we've talked about in the last 2 chapters, but now applying them to e's. But nothing has changed. It's the exact same rules. Now we just got e's in the mix. Now graphing. This is going to be identical to what we've done the last couple days. We're going to have some growths and we're going to have decays. This first one, a times e to the x. The only difference between this and what we did in the past is this is an e. But remember, we said e is just like what? E is just like 2.718. So when I look at my b, and that's what's telling me this is a growth, remember? My b is 2.718. That's greater than 1. That's why this is a growth. B is greater than 1. When I look at the b here, this is 2.718, yes, but this is a negative power. So what does this tell us? Since this is a negative power, this is actually 1 over e to the x. Since it's 1 over, this is now a fraction less than 1. And since it's less than 1, this one is a decay. So you really got to be careful when you see these powers. That's a negative power. Bringing it to the bottom makes it decay. That makes it less than 1. Now, if you were to type these in your calculators, you would also see that. This first one, here's your a times e to the x. It's going up, so that's our growth. A times e to the negative x, coming down, that's our decay. Okay, and again, don't forget, anytime you see e, it's just like 2.718. Now, we're going to look at two questions. We're going to do the same thing we did before. Graph, asymptote, y-intercept, domain, and range, but now these two questions are going to have e's. The first one, here's my example. First thing I have to decide is if it is a growth or a decay. Well, this is my A. I'm not concerned about that right now. I want my B, and remember the B is always attached to that power. So when I'm looking for growth or decay, here's my B. So my B is e to the 0.5x. So what does that mean? Is this growth or decay? E is 2.718. That's greater than 1. So therefore, this is a growth. Now, if you haven't yet, type it in your calculator. Negative 3 times e to the power of 0.5x. Remember, e is just a button. It's just a button on your calculator. So negative 3 times e to the 0.5x. You'll get a picture similar to this. Now, let's reference this picture to everything that we've been talking about the last couple days. Okay, first thing, y-intercept. How do we find the y-intercept? Remember we said the other day, a y-intercept is wherever x equals 0. So we got to plug that in and see what we get. So if I plug in x equals 0, I get negative 3 times e to the 0.5, and x has to be 0. Well, what is 0.5 times 0? 0.5 times 0 is just 0. So I have negative 3 times e to the 0. Anything to a 0 power, remember 0 power, it's like nothing's there. So anything to a 0 power is just 1. So negative 3 times 1 is negative 3. So my intercept is 0, negative 3. And if we were to reference that with our graph, look over here on our graph, crosses right through negative 3. Now our asymptote. Remember our asymptote was that k in our equation. And when I look up here in my equation, there's no k. There's no plus or minus out here on the outside. So since there is no k, remember our asymptote is y equals 0. Now when I'm going over to my graph to draw it, remember we always draw our asymptote with a dotted line. Okay, so draw your dotted line right through that axis, right through y equals 0. So y equals 0 is my asymptote. My intercept is at 0, negative 3. Now, domain and range. Domain, just like we talked about the other day. This arrow over here is going to keep going to the left. This arrow down here is going down. It's also slowly going right. So domain is still negative to positive. Range, we are going down, so we're going down to negative infinity. And then we're slowly coming up, and we're stopping at our asymptote. Our asymptote is the highest place that we'll ever get. Because remember, asymptote means you get as close as you can, but you never cross. So the asymptote's as high as we get, so the highest we get is 0. Remember, we don't touch it, we don't cross it, so we need a parenthesis. Okay, let's look at our next one. Growth or decay? Well, here's my b, attached to the power. There's no negatives up here. Remember, e is just 2.718, so therefore this is a growth. Okay, and if you haven't yet, again, start typing it in. E to a power of 0.4, x plus 1, minus 2. Now, before I even show you my picture, I'm going to solve these first two. My asymptote. Remember, asymptote is always whatever's on the outside. So my asymptote for this question is y equals negative 2. Y-intercept, again, plug in 0. So I get e to a 0.4 times 0 plus 1 minus 2. Well, that gives me e to a 0.4. 0 plus 1 is just 1 minus 2. Well, what's 0.4 times 1? 0.4 times 1 is just 0.4. Plug this in your calculator. Again, use your calculator for these e's. E to the 0.4 minus 2. Your calculator is going to give you a value of about negative 0.508. So my intercept is 0, negative 0.508. Now, let's see if that matches with my picture. We said our asymptote was at negative 2. So if I look at my picture, here's my negative 2. If I were to start to draw my line going across here, and I continue it, it matches. So that's my asymptote, and we said my intercept was negative 0.508. The negative 0.5 is about 1/2. And if I look at my picture, it's pretty darn close. 0, negative 0.508. Now, domain and range. Again, domain hasn't changed. Going all the way to the left, this is slowly going to the right. So domain is negative infinity to positive infinity. Range, I'm going up this time, so I'm going up to positive infinity. And where do I start? Remember, I'm not starting at that intercept. What is my lowest point? My lowest point is down here at my asymptote. So my lowest point is at negative 2. Okay, so graphing very similar to what we did the other day. Now we just have an e. Now, little review. Remember we had our compound interest talked about yesterday, and we talked about at the beginning of this notes. So here's our equation. P is what we put in, R is our rate, N's our compounds, T is our time. We're going to get another equation that's going to be very similar to this. There's only going to be one difference. Instead of having an N, remember N was your daily, your monthly, quarterly, semi-annually. That was the compounds. Instead of having those words, this new equation is going to have a different kind of compound. This new equation is going to say continuously compounded. Okay, what does that mean? If it's continuously compounded, it is compounding all the time. It never stops. Okay, think about what we said at the very beginning. If it never stops compounding, you're getting more and more and more interest every time. Okay, so this is the maximum interest equation, continuously compounded. And if you see that word continuous, you have a new equation. A equals PE power RT. Okay, so this is my PERT. I always call this my PERT equation. So if it's continuously compounded, it's our PERT. A equals PE to the RT. Everything's the same. A is still your total. P is still your deposit, what you put in. E, remember again, E is just a button, 2.718. R is still your rate, T is still your time. Okay, so let's look at our example. You deposit $1,500 into an account that pays 7.5% annual interest compounded continuously. What is the balance after 2 years? Almost identical to questions that you had in the last section, except this word, continuously. So since you see that word continuously, we know we're using PERT. A equals PE power of RT. So let's plug in what we know. You deposit $1,500. So that's what we're putting in. So A equals 1,500. E, again, it's just a button, 2.718. So E, R, and T. Well, my R, 7.5, again, you got to move it over. So 0.075. My time, 2 years, 2. Now, you can probably plug it in like it is, or if you want to make it a little bit easier, you can do the 0.75 times 2 and make that 0.15. Okay, but either way, you're plugging it in. Remember, E is your button, 2.718. You plug that in. After 2 years, your $1,500 times e to a power of 0.15 has become $1,742.75. So very similar to what we did yesterday, but since we have this word continuously, we got to make sure that we know we're using this P e to the RT equation. Hope you enjoyed the lesson. Plenty more to come. You'll get your homework tomorrow in class.